Okay, notes 10.1, we're going to be sketching polynomial functions. A polynomial, remember, is the sum of monomials. So on the front, we're going to be using the graphs on the front in order to figure out the direction of our polynomial functions. Okay, so we're going to be graphing f of x equals x cubed. Remember, that is the cubic parent function. The smallest x value that we can plug in for it to plot on the graph is -2. -2 cubed, you get -8. -1 cubed, you get -1. 0 cubed, you get 0. 1 cubed, you get 1. And 2 cubed, you get 8. So we've already looked at what a cubic graph looks like, but let's go ahead and plot these points. So it will be increasing from left to right. Okay, something you need to know for once we get to graphing the polynomial functions. Okay, so number 2, notice it put a negative in front, which reflects it across the x-axis. Also, it changes your original y values to the opposite sign. So instead of it being -2, -8, it's -2, +8. -1, 1. 0, 0. 1, -1. And 2, -8. So when it's negative, it should be decreasing from left to right. Alright, so looking at number 3, we have f of x equals x to the 4th. So I'm going to plug in, we haven't looked at this before, this is a quartic graph. Okay, so the smallest number that I could plug in and raise it to the 4th and it be on the graph is -1. -1 to the 4th power would give us a +1. Even anytime that exponent is an even power, you should end up with a positive answer because a negative times a negative is a positive. Plugging in 0, 0 to the 4th is 0, 1 to the 4th is 1, 2 to the 4th is 16, so we're not able to plot that. So these are the only ones that we're able to plot. So notice that it's a parabola. Okay? Alright, so the -x to the 4th, we would have 0, 0, -1, -1, 1, -1. And there's our graph. It opens down. Okay, so we're going to be using this information in order to graph at the back. Alright, so we're going to be sketching the graphs of each polynomial function using roots of the function. Remember, roots are your x-intercepts, so where it crosses the x-axis. Notice we're not going to be using a y-scale, so we're not going to be looking to see how high we're going or how low we're going. We just want the general idea of what the graph would look like and where it would cross the x-axis. Okay, so notice all of these polynomial functions that we're given are already factored for us. They already has the factors. So to find the roots, you're setting each factor equal to 0 and finding x. Okay, so x plus 1 equals 0, x would equal -1. X minus 1 equals 0, your root would be 1. X minus 3 equals 0, x would be 3. So overall, we have 3 roots. So it would be cubic. That's what it's going to look like overall. If you look in the very front, you need to check and see if it's positive or negative. Notice there's not a negative sign there, so we know it's positive. Remember, from the front, a positive cubic increases from left to right. So overall, that's what our graph should look like. All right, you're going to plot your x-intercepts, which are your roots. It crosses the x at -1, +1, and +3. All right, so we want to increase from left to right because that's what our positive x cubed looks like. Okay, so from left to right, if I start at the very far left, I need to start at the bottom. I'm going to be going through each root and then curving back to get to your other root. So overall, it should be increasing from left to right because it was a positive cubic. All right, so number 6, we have a root at -2. a root at 1, and a root at 4. So overall we have 3. And notice in front on this one it's negative, which means it should be decreasing from left to right. So we have -2, +1, and +4. From left to right, it should be decreasing because it was negative. So we're starting up at the top. Remember, it's only going through the roots that we were given, okay? You shouldn't make new roots. It only crosses the x-axis at -2, 1, and 4. So overall, it should be decreasing from left to right. All right, notice on 7, f of x equals x plus 3 squared. That means you have a double root. It's the same thing as having x plus 3, x plus 3, and x minus 2. So we have a root at -3, another root at -3, because that's why there's a double root, and then you have one at +2. So overall it's cubic because there's 3, and then if you look in front it's positive. So it should be increasing from left to right. So we have -3, +2. Now, at the double root, it's x squared, so it needs to look like a parabola. So instead of going straight through it like we did on the other 2 examples, you have to curve it back to make it look like a parabola. So we're increasing from left to right. So we'll start at the bottom. At the double root, it should look like a parabola, and then curve it back to get to your other root. So you should be able to determine by looking at the graph there's a double root there, because it curves like a parabola. Okay, so 8. Notice we just have an x. If we set that equal to 0, x would be 0. So our root is 0. If you have just an x, it's 0. Root would be -4 and +1. So we have 3. Notice in front's negative, so it should be decreasing from left to right. So that's just helping us with knowing overall what it's going to look like. Alright, so we have a root at 0, -4, and +1. So from left to right, you should be decreasing. So I'm going straight through each point because I don't have a double root on this one. Alright, looking at example 9, we have an x. We just talked about that. If you have an x, the root is 0. Then we would have -5, -1, and 2. So notice this time we have a total of 4, which is quartic. In front it's positive. So remember, from the front, it should be a parabola that opens up. So that's the direction of it. It should be opening up. So we have a root at 0, a root at -5, and a root at -1, and a root at +2. So it should be opening up. We don't have any double roots, so we're just going straight through each one. And overall, it should be opening up because x to the 4th opens up. All right, 10. We have a root at -3, -4, 2, and 4. There's 4. It's negative, so that means overall it should be opening down. So I have a root at -4, -3, 2, and 4. It should be opening down, so I'm going straight through each one, and I messed up. You should be going through the points. don't need to create new roots. So overall, it should be opening down. Again, we're not using the Y scale, so on these, we're just looking at what it would look like overall. So we aren't really paying attention to how high and how low they're going on the Y-axis. Okay, 11, notice we have x squared. When we have just an x, our root is 0, so x squared would be a double root at 0. And then x plus 3 squared is also a double root. That would be at negative 3. So we have 4 overall, and it's positive. So that should be opening up. So double root at 0, double root at negative 3. Alright, so remember, at your double root it should curve back like a parabola. So we need to start at the top. It's a double root here. It's also a double root there. So it should not be going below the x-axis on this example. If it was negative on this example, it shouldn't be going above the x-axis, because they both were double roots. Alright, notice on 12 we have f of x equals negative x plus 4 cubed x minus 1. So anytime you're cubing it, that means you have 3 roots, so that would be called a triple root. And we would have a triple root at negative 4, and then a root at positive 1. So overall there's 4, and there's a negative in front, so it should open down. Triple root at negative 4 and a root at positive 1. So at the triple root, remember we talked about on the double root, it should curve like a parabola because that's x squared. Since we have a triple root, that would be x cubed. That would look like a cubic at the triple root. So make sure that when it's opening down, so start at the bottom. So at the triple root, you need to flatten it out or indent it there. So that way you are able to look at it and know that there's a triple root there. Do not do this. It should flatten out at the actual triple root. Okay, so this is sketching polynomial functions. You are having to find your roots, and then you are figuring out what overall it's going to look like, and then you can graph it.